So let a change in internal energy be brought about in a system by doing some mechanical work. Let 1 kilojoule of mechanical work be done on the system. And what is the system taken here? It is some quantity of water taken in a thermos flask. Since water is taken in a thermos flask, there will not be any heat exchange between the system and the surroundings. So we have an adiabatic system. Let the initial state of this system be denoted as A, so that the initial temperature is TA and the initial internal energy will be UA. Now how can 1 kilojoule of mechanical work be done on the system? It is done by rotating a set of paddles. When the paddles are rotated, heat energy will be produced. But this heat energy produced cannot leave the system since the system is adiabatic. So the heat energy produced will be taken up by water, as a result of which there will be a rise in temperature. When 1 kilojoule of mechanical work is done, the system will be taken to a new state called as B. It is taken as the final state where the temperature is TB. Now how can we get the change in temperature? We know the initial and the final temperature. So change in temperature delta T will be equal to TB minus TA. That is temperature of the final state minus temperature of the initial state. Now what will be change in internal energy delta U equal to? It will be equal to UB minus UA. Now instead of mechanical work, let 1 kilojoule of electrical work be done on the system. Note that here instead of mechanical work we are using electrical work, but the same amount of work is done on the system. It is 1 kilojoule of work. Now how can this electrical work be done on the system? By keeping an immersion rod. So when 1 kilojoule of electrical work is done on the system, there will be a change in temperature. Since the work done, the amount of work done is the same, the system will move to the same final state B. So the change in temperature delta T can be taken as equal to TB minus TA. It is found that a given amount of work done on the system produced the same change of state. So if the amount of work done is the same, then the system will be brought to the same final state. It is found that adiabatic work done required to bring about the change of state is equal to the difference between the value of internal energy in one state and that in another state. So here what type of work is done? It is adiabatic work. And this work is required for what? This work is required to bring about a change in the state. Here the system has changed from the initial state A to the final state B. So to bring about the change of state, we have done some amount of work, adiabatic work on the system. Now what is this adiabatic work equal to? It is equal to the difference in internal energy. That is delta U is equal to U2 minus U1. So work done adiabatic can be taken as a measure of the change in internal energy. So that is why we can write the equation as delta U is equal to work done adiabatic. If work is done on the system, it is given a positive sign. Now if work is done on the system, there will be an increase in internal energy. If work is done by the system, it will be given a negative sign. And if work is done by the system, the internal energy of the system will decrease. Next we shall see how a change in internal energy can be brought about in a system by transfer of heat. The transfer of heat will take place only if the system and the surroundings are at two different temperatures. There can be transfer of heat either from the system to the surroundings or from the surroundings to the system. When will there be a transfer of heat from the system to the surroundings? If the system is at a higher temperature. Now if the surroundings is at a higher temperature, then the transfer of heat will be from the surroundings to the system. So this exchange of energy, which is a result of temperature difference, is called heat. Now what is the system to be taken here? The system can be water taken in a copper vessel. The container should be a conducting one. Then only there can be a transfer of heat. Now let the temperature of water in the copper vessel be taken as TA. This water in a copper vessel is the system and it is enclosed in a huge heat reservoir. The temperature of the heat reservoir is taken as TB. Since it is a heat reservoir, the temperature TB will be higher than the temperature TA. Since the heat reservoir is at a higher temperature, there will be transfer of heat from the heat reservoir to water in the copper vessel, as a result of which the temperature of water will increase. So how can we take the temperature difference? Delta T will be equal to TB minus TA. So here change in internal energy delta U is equal to the heat absorbed Q. The heat absorbed by water Q gives us a measure of the change in internal energy. In the previous case, it was work done adiabatic, which gives us a measure of the change in internal energy. But here, it is the amount of heat energy absorbed by water that gives us a change in internal energy. So that is why we have written delta U as equal to Q. Note that here work is not done at constant volume. If heat is absorbed by the system, Q will be taken as positive. And if heat energy is absorbed by the system, there will be an increase in internal energy. Now consider the second case. Heat energy can also be released by the system. So if Q is negative, then there will be a decrease in internal energy. Thus we have come to know that change in internal energy delta U is equal to work done adiabatic, and change in internal energy delta U is also equal to the amount of heat energy absorbed Q. Now when we combine these two, we get the general case, that is delta U is equal to Q plus W. This equation represents first law of thermodynamics. So how can we state first law of thermodynamics? It can be stated as the energy of an isolated system is constant. This is also known as the law of conservation of energy. We know that energy can neither be created nor be destroyed. So this law of conservation of energy is put in another form, which is known as first law of thermodynamics. And what is the statement? The energy of an isolated system is constant. Now consider the equation delta U is equal to Q minus W. When will W work done adiabatic be given a negative sign? When work is done by the system. So that is why we have the equation delta U is equal to Q minus W. So here minus W denotes that work is done by the system. And what about Q here? The sign of Q is positive, which shows that heat energy is added to the system or it is absorbed by the system. So change in internal energy delta U is equal to heat added to the system minus work done by the system.